Welcome class, this is a continuation of lesson 2.2b. So we're going to do some similar questions but in forms of word problems. So here are some application problems with quadratics. So in this first example, it says use the quadratic equation to find the maximum height in feet of the basketball that basketball reached after some time in seconds. So here's the equation they give you. Notice this is already written in vertex form. So this is my h and this is my k. So it's already written as something parentheses squared plus a number. So that is my vertex. I'm going to write my vertex here as a point. So remember, you want to move the opposite direction. This is a minus, so it's going to be to the right by 10.76. And then this is plus, so this is up 14.8. Okay, so if you give yourself a quick sketch of this, I'm going to just sketch a little picture of this. This is typically most of these story ponds will always look like this. Okay, so they're saying that this maximum height here is in the x direction to the right, 10.76, and it's up, which is our y value, up 14.8. So to answer the question of maximum height is how high did it go? So you want to think which of these numbers represent how high that maximum is. And how high is a y value? So that would be 14.8. Okay? And it says when. When is a time is that they're asking for. When did the ball reach that maximum height? So at the highest point, how much time has passed? So that's really what is x. So here I'm going back to that point. I want to know what time, how much time has passed, and that would be the x value of my vertex. So that is 10.76. Now, just to be sure, remember you can graph this in your graphic calculator as well and find that value just in case you didn't realize this. So I'm going to switch over to Desmos. So I have that ready here. And I typed this in already for you. So if you want to use your keyboard to type this in, remember the keyboard's right here in this lower left corner, or you could just type it in. Notice this graph is really big, so I'm going to have to zoom in a bit. And let's slide this over so I can look at that maximum. If you peek and just touch, it should appear. And there it is. If you touch it, it'll tell you where that maximum is also. So if you didn't realize that was in vertex form, put it in Desmos and you can see that peak as well. Okay? All right, let's go back and try some other examples. Okay? All right. For the second example, here's the problem. It says the parabola shows the path of your first golf shot. So this is the golf shot right here. This is already showing the path of the first golf shot. It says x is horizontal, distance in yards, and y is the height, also in yards. So how high did it go? How far? The path of the second shot can be modeled by this function. So they give us this equation, and this is a different path. So this is going to be our second shot. Okay. So we'll have to take a peek at what that looks like in order to answer a lot of these questions, right? So for this one, it says height of first shot. We're going back to the first picture, and we have to determine which one represents the height of it. And this is also x, and y is part of our vertex, your h and your k. Remember, y tells you how high. So the height of the first shot is 25 yards. Everything was in yards. The distance traveled of the first shot. So yes, I know the ball bounces, so we're assuming we're not counting all the bounces. It goes in the sky and it drops and it hits the ground right here. So that right there is a distance of 100, ignoring all the bounces that the ball makes or rolling, okay? So that would be 100 yards, okay? And it says, note, because parabolas are symmetrical, so it's perfectly even left and right, the vertex is in the middle. That's how I know perfectly between 0 and 100 is that 50. Okay? It says, find the height and distance traveled of the second shot. So that's where I'm going to go to this equation right here. I'm going to use Desmos again to type this in. Remember, f of x is y. Okay? So I'm going to go to Desmos, I'm going to type it in. We're going to try to get the sketch of this graph. So let me jump back to Desmos and let's take a look. So I'm going to get rid of this one. I already typed it in earlier. So here's the equation. I just typed it in just like they show you. Type everything as you see. Again, my graph's a little bit big, so I'm going to have to kind of zoom out a little bit. And I'm going to touch where that peak may be. You just touch it a few times, and it tells me right there. I'm going to sketch this into my graph, and the vertex I'm drawing on my paper right now. It's just a sketch, but that vertex, that top point, is 40, 32. So you want to draw that and label on your notes so that you know how to answer the questions, okay? All right, so I just drew this and I labeled that vertex right there. Okay, so that's going to help me answer some questions as well. All right, so now I did. It says find the vertex using a graphing calculator for that max. So that's why I use Desmos.com. The height of the second shot is how high. Remember, the Y tells you how high, so that is 32 yards. And sketch the picture. We did the distance traveled of the second shot. Oh, I'll probably have to go back to Desmos for that. I want to know how far did it travel. So that's this part right here. Where did it touch the ground? We're saying that this right here is 0 height. Okay, so how high? Where to hit the ground? It's at 0. So let's go back to Desmos and check real quick. My guess, if I graphed this correctly, if it crossed here at 0, this should be double. It should be 80, but let's be sure. I did not look earlier. So let's take a look. And yes, look at this. It crossed exactly at 80 and 0. So it's going to hit the ground 80 yards away. Okay. All right. So let's answer that question. It says the distance traveled of the second shot, 80 yards away. It touched that ground. Okay. All right, there's only one more example, and that's really is your turn. So I want you to pause the video. This is the one where you're going to try. Really take your best effort, pause the video here, and then replay it when you're ready to check to see how well you did. Make sure you try your best to answer these 3 questions for these problems, okay? I will give you a hint when you use Desmos. H of t is kind of like f of x, which we just type in y. That's our output, our result. And when you're graphing either graphic calculator or Desmos, we don't use t's, okay? We do use x's for time. So you want to type in negative 16x, use the exponent key squared plus 20x plus 6. This is what you're going to type into Desmos, okay? So pause, give it a try, and then replay the video. All right, I hope you had a chance to try. So let's take a look at what this graph looks like. And I did input it right here. So let me double check I typed it right. Negative 16x squared plus 20x plus 6. So there it is. Oh, it's small. So that's because I had zoomed out earlier for the other graph. I'm zooming in now so I can see. It does help also to sketch. So I'm going to make a sketch of this on my paper so I can graph. It is quite small, but we are just sketching it so that we can label, okay? So very important points that they typically ask for is this vertex point. So I'm going to click on it. I'm going to label on my picture the x value, 0.625, and the y value, 12.25. The other question they ask for is where does it land? That's another typical question. So I'm going to go ahead and record that right now. So it touches the ground again at 1.5 seconds. The other x-intercept here is in the negative. Because it's a story problem, we're not going to go in the negative world. So we're not going to go back in time for 0.25 seconds. So I'm going to record the positive time. Okay. All right, let's go back and make sure these questions are answered properly. So there's my sketch. I did not draw as skinny as what Desmos was showing because I just wanted to label everything properly. It says which is the maximum height. Remember, height is how high, so it's how far up. And x, the y value, tells how high. So that is the 12.25. Okay, and I'm looking for units, but you know what? I think I probably forgot the units on this one. Height, how long does it take? You know what? I forgot to put units in. Let's just guess is in feet, okay? I don't know. So we'll just guess if this is basketball, 12.5 or 12.25 feet is pretty high. When, which is the time, that's an x value. When, what time the ball reaches the max. So right at the tip point of the height, when did that happen? So up here, how far or when in time? This right here, very fast, 0.625 seconds. That's a very quick ball. What time does the ball hit the ground? So the height will be 0. Height is down here at 0. This is that time again, the when. So 1.5 seconds later, it will hit the ground, okay? So this one wasn't exactly double because it wasn't starting at 0. Maybe this is a very tall person who started up here at 6 feet tall. So the ball wasn't recorded exactly from the ground, okay? So that's why it's not double this value, okay? So use Desmos and then sketch. Just answer the questions carefully of what they're asking for, okay? All right, that is the end of our additional examples for lesson 2 to B, okay?